Okay, folks, let's get underway. So, this is going to be your first lecture. All the lectures will have basically the same format. So, I'm going to give you kind of an introduction to what's going on. Then we'll switch over to the PowerPoint. You'll still see me up in the corner up there because I do things with my hands that sometimes you need to watch while it's going on. But overall, what you want to do is make sure that you have your class notes out and with you. So, for this one, it looks like this on both sides. And you'll notice that down here at the bottom, there's an area where you're actually going to be filling things in. When we get to that point, I'm going to tell you to pause the video, and then you're actually going to work through that. And it may take you 5, 10 minutes, something like that, to do that particular part. You're welcome to do that in groups and discuss that. A lot of times, what you're working with here is giving you the experience that you need to do the homework as well. So it's really important that you do it. I know it's really easy to just sit there and go, oh, yeah, I'm just going to let it run and I'll go back and do it later. Don't do it. An online class is hard enough. Don't make it harder on yourself. The way we've got this set up, you really need all the components of it. You need the lecture where we're doing these worksheets with that. You need the homework and you need the lab to make this all work together. If you miss any one of those three, you find yourself struggling and it gets really hard. If you're devoted to doing all three of them, then it seems to just all fit together and you're having fun with the class. And it's we used to say in the Navy, if you're not having fun, you're not doing it right. So what we're going to talk about is finding aliens. I mean, basically the whole idea of this course is, are we alone? So how will we determine the answer to that question? And we are just now getting to the point in astronomy and in science to where we can actually come up with a reasonable answer. And if we don't have the complete answer, we at least know what we need to find out in order to get a definitive answer. So let's get started. Okay, so if you want to download the PowerPoints, you're welcome to do that. I actually don't, for most people, I don't think you need the PowerPoint before you're watching the video, but some people like to have the PowerPoints available. They'll have them printed out just so that they can, kind of make notes to help them remember what's going on. By the end of the course, then you've got this very nice review packet that you can use when you're doing your final project. But you're going to find that these worksheets pretty well summarize everything that you're going to need to by the time you get to your final project. And it's just front and back of one page. So it's not a whole lot that you've got to keep up with. So have this out, have this sitting over to the side. You're going to want your pencil and have everything ready. All right, let's get underway. So this is tool number 1, finding aliens. So if you're having trouble finding that, that's on the website. Look on the modules for week 1, and then you'll see the finding aliens class notes, and that's the one that you're going to download. Now, we're not doing the homework just yet. The homework you're going to do on your own. We're not going to have a video that will go along with that. However, as always, if you've got questions on the homework, then you want to come into live help or post on the discussion. So if you've ever thought about it, and you ever go out when it's dark outside, when you can actually see the stars. Of course, in Phoenix, you're going to be getting out of Phoenix if you're going to see many of the stars. We really can't see much of anything but the brightest stars here in Phoenix. But you don't have to go too far out of town before you can actually start to see something. So if you've ever been out camping or on a boat or something like that, and you look out in the night sky and you ask, are we alone? And fundamentally, that question seems to, you think, well, maybe, but when you start to see how many stars there are out there, there are over 100 billion stars in our galaxy. And this is not an actual photograph. This is actually an artist's conception. It's a space artist. Space artist is an actual astronomer who, unlike me, can draw. I can't draw. It's a big joke whenever we're in person, my attempts at drawing on the board and things like that. So everything that you're seeing here, though, is actually very realistic. It's done based on the latest data. We're actually right about here in this spiral arm. It's called the Orion arm right here. And I'll show you some close-up pictures of that. But everything that you see here is actually a star. It's all blending together just because there are millions and millions and millions of stars right here in the middle in particular. That's not just one big bright star. That's a whole bunch of stars, and they're so close together and they're so bright that their light is being blended together. So there's over 100 billion stars in our galaxy. And in the universe, there's over 100 billion galaxies. So when you look at this picture here, every single thing you see in this picture is a galaxy. Every tiny little dot. The brighter ones are just closer. And then if you look over here, you can see some of the dimmer ones. This is actually taken by the Hubble Space Telescope. It's called the Hubble Deep Field. But each one of these galaxies has 100 billion stars in it. So you think about how many that stars that is. What are the odds that there is exactly one planet in all of this that has life on it? Now, I do want to say one thing. While astrobiologists, which is what we're going to be talking about here, when we're talking about finding life in the universe, they would be tickled pink just to find a microbe. They would pee their pants. They'd be so excited if they found an alien life form that was even a microbe. For this class, our bar is set higher. We not only want to find life, but we want to find intelligent, technologically capable, communicating alien life. When most people talk about aliens, that's what they mean. They don't mean little critters or bugs or things like that running around. They want somebody they can actually talk to, somebody they can interact with. There are those, of course, who believe that they're already here, and we'll talk about that at the end of the class. So, whenever you gaze out in the sky and you're looking at these stars out there, and you're looking at all these hundreds of billions of stars, have you ever wondered, is somebody looking back at you? Well, spoiler alert, the answer is almost definitely yes. There is virtually 100% chance that somebody is actually looking back at you wondering, I wonder if there's any life out there from that. And one of the things that we're going to do in this class is we're actually going to calculate how many intelligent, communicating, technologically capable alien civilizations there are in the galaxy. And for practically all of you, you're going to find that the answer is not one. Some of you may get a whole lot, some may get just a few, but almost nobody is going to find that they're one, that they're going to find that there's a whole lot more than one out there. So here on Earth, we've been using not only the Hubble Space Telescope, but a spacecraft called Kepler, which is looking for planets. It's using the same technique that I'm going to be teaching you in this class. So all of these planets that you see here, these are actual planets that we found. We found over 3,000 planets that are confirmed right now, and about another couple of thousand that are candidates that we're pretty sure are also planets. Using the techniques that we're going to show you, that's how we were able to find them. And so basically from those, we were able to see some of the different characteristics from that. We were able to tell something about their atmosphere, their gravity, things like that. So we know for a fact that there are planets around at least some of those stars, and it certainly kind of looks like most of those stars have planets. But the question for us then is, which one of those planets are habitable? Now, in our own solar system, we have 9 planets because Pluto's a planet, damn it. Ask me later if you want to know why. But not all of those planets are actually habitable. Some of them are gas giants, Jupiter, Saturn. Some are what we call ice giants, Uranus and Neptune. But some of them are terrestrial worlds. These are rocky worlds. They've got a surface that you can walk around on. Mercury, Venus, Earth, Mars, all of those are terrestrial planets. They're rocky terrestrials. Pluto is what I would consider an icy terrestrial. But it's got a surface. You can walk on it. But Mercury is absolutely not habitable. It is too hot. It keeps only one face, not quite, but it's in resonance. So it spends a lot of time with one face facing the sun. So it's even hotter than what you might think. Venus, we think, used to be habitable, but isn't anymore. And Earth, of course, is currently habitable, but we're on the way to becoming Venus, and we'll talk about that later on in the class too. Mars, we also think used to be habitable, and now somehow it lost most of its atmosphere and started to get very cold. So, what is it that makes a planet habitable? And how will I figure that out just by looking at it through a telescope? So that's one of the things that we're going to be teaching you in this class is not only how do I find the planet, but could there be life on that planet? So the whole question of are we alone is a really big question. It's not something you can just answer just by taking one piece of data and calling it good. So there's a lot of information that we're going to need in order to answer that question. So here's where I want you to pause the video, look on your worksheet. So you'll notice that there are 5 places. I want you to come up with 5 questions or pieces of information that we would need to know to answer the question, are we alone? All right, so pause the video and then come back and do that. Did you pause the video? Seriously, pause the video. Okay, I'm going to trust that you're back and that you've actually paused the video. Now, if we were doing this in person, we would actually share some of these examples here. And what we take them, write them up on the whiteboard, get some ideas about what the different things are. And generally speaking, almost every question that you would want to know can fall under one of 3 disciplines, one of 3 sciences. So let's look at that. So astronomy, which by definition is looking at the stars, the study of the stars. It is not astrology, by the way. That is okay, different. But go to Sedona if you want to study astrology. But astronomy is actually the scientific study of the stars. So if we're wanting to find out things like what kind of stars are out there, how long does a star live, how hot does it get? Because think about it. If I've got a planet and it's this far from its star, is it habitable? Well, it depends on how hot the star is. Let's say that the star is really, really dim. If I've got a planet all the way out here, what are the chances that it's warm enough to be habitable? Basically zero, right? The only way it's going to be habitable is if it's just right next to its star. On the other hand, if I've got this great big honker, ultra blue white hot star, and I've got this planet right here, that planet's toast. There's no chance. I actually need it to be all the way back here. And then it'll be about the right temperature. So there's a couple of things that I would need to know that astronomy can tell me. What is the temperature of that star? Is it a kind of middle range, like our own sun? Is it very dim, like the nearest stars to us, and some of which we think we found a habitable world around? Is it really, really bright, which would mean that the planet would have to be a long way away from the star for it to work? How far away is the planet from the star? How do solar systems form? Some other things we would need to know is how long does that star live? One of the things we're going to find is that the really big, bright stars don't live very long. Some of them may only live for 10 million years. So if you think about that, the dinosaurs were here 65 million years ago. When they turned their telescopes up to the sky, they saw a different sky than what you see today because some of the stars that we see now hadn't been born yet. So if the star only lives for 10 million years, we think it might take a couple of billion years for life to arise. So chances are that planet isn't going to have any life around it, even if it's in the right zone. It could be a colony world for us, but it hasn't developed life on its own. So these are all the kinds of questions that would fall under the category of astronomy. So this is what astronomers would study. So planetary science, you probably know that as geology. We used to call that geology all the time, except geo means Earth. And now we've actually been able to land on other planets. We've got rovers on Mars. I worked on the Mars program for a number of years. And we've got rovers on Mars. We've got spacecraft in orbit. We've got spacecraft that are studying Venus. We've got spacecraft that are studying the moons of Jupiter. So we're not just studying Earth anymore. We're studying planets as a whole. So we call it planetary science. But it's still basically the same thing. What processes are going on the planet that make it habitable? Well, one of the things you're going to learn is that all planets are losing their atmosphere continuously, including the Earth. The only reason that we have an atmosphere is because we have active volcanoes. If for some reason the volcanoes on Earth stopped, all of our atmosphere would get blown into space, it wouldn't be replenished, and we'd all die. So, what makes those volcanoes? What keeps those volcanoes going? On Mars, we think what happened to it was its active volcanoes turned off. When that happened, it lost a lot of its atmosphere. When it lost its atmosphere, it got colder. When it got colder, more of its atmosphere froze to the ground, and so on and so on. We call that the runaway refrigerator effect. On Venus, for some reason, all the volcanoes on Venus erupted at essentially the same time. Okay, within a million years or so. But they erupted at essentially the same time. This put so much carbon dioxide in the atmosphere that the atmosphere got very thick. That caused it to heat up, which caused it to get more atmosphere from the ground outgassing, and it got thicker and thicker and hotter, and that's what killed Venus from that. So understanding how these processes work on the planet not only tells us, well, what's the likelihood that the atmosphere is going to survive, but also what's that atmosphere made out of, because that's going to tell us what these things can breathe. Which leads us to the next one. When we're talking about the aliens themselves, we're talking about biology. So remember, we're wanting to talk about people that we can actually communicate with. But what are they like? Are they necessarily going to be life as we know it? Are they going to look like us? Are they going to have, 2 arms and 2 legs and things like that? And the answer is probably not. But one of the things you're going to do for your final project, after you have found your habitable alien world and you figured out all its characteristics, you're going to figure out what the aliens on that world look like. Not only are you going to figure out what they look like, you're going to figure out what their society is like. All of these things we can tell by studying biology from that. And so with biology, we not only can figure out, what are the processes of life, respiration, metabolism, things like that, but also where did life come from? How long does it take for life to appear? And what made that magic jump from chemistry to biology to where we actually consider it to be alive? So 3 very different sciences all have to come together to form this one science that we call astrobiology. So if you're interested in studying aliens, you are an astrobiologist. And it's only been in the last 10 years or so that this science has even existed. But now you can actually get your degree in astrobiology. ASU actually has an astrobiology degree program. So if this is something that's interesting to you, you absolutely can do it. And you will probably know a lot about all three of these, but generally speaking, you specialize in one or the other from there. So we've got some other things that we've got to think about, though. So what technology are we going to use to find them? Well, obviously we're going to need to use a telescope of some kind, right? Because we're looking at tiny stars. The stars themselves are actually huge, but they're oh my god far away. How are we going to talk to them once we've identified that there is an alien there? How are we going to communicate with them? What are we going to send a laser beam? Are we going to send a radio message? Are we going to use Morse code with nuclear bombs going off or something like that? All these things have actually been seriously proposed. So we got to figure out what technology we're going to use to talk to them. Once we've got the technology, what are you going to say? And one of the things that we're going to talk about here, I'm going to show you some actual messages that we have sent to aliens that we have tried to, encode a message to them. And you're going to see that some of them were not a terribly good idea, but we'll get to that. And then if we have time, maybe I'll show you some possible messages that we've received from aliens, but that'll be at the end of the semester. So will we be under, if we send a message, will it even mean what we think it does? You know? So and finally, are they already talking to us? It could be that there's messages out there, but it's like finding a needle in a haystack. We think we may have seen some possible signals that might, maybe, who knows, be from aliens. But remember, this is very important. Extraordinary claims require extraordinary evidence. If you can't prove something of this magnitude, then this is probably not something that we could accept. Because think about it. How would our civilization change if we had proof that aliens were out there? Just think about religion, just as one case. But it's going to actually percolate all throughout everything in our society. So it's a big deal. If you're going to make a claim like that, you've got to have the evidence to back it up. So then the question is, where are they? Well, Kepler has been studying just the planets, it's been detecting planets just in our neighborhood right here, and then a few that it's been able to see in this direction. So, but for the most part, everything's been right around in this area. And that's just an artifact of the range that Kepler has. Beyond that, then the differences in finding these planets using the technique that we're going to teach you is just going to be too small for you to see. But that's okay, because we found 5,000 planets just in that little circle. And realistically, if we want to communicate with the aliens, they need to be close by. We don't yet have faster than light travel. So all of our communication is restricted to being the speed of light. The closest star system to us, the Alpha Centauri system, has a planet. It's possible that it is habitable, and it's about 4.5, a little less than 4.5 light years away. So that means just to get a signal to them, you send them a message, and in return, you're looking at 9 to 10 years before you're just going to get a "Hi, how you doing?" from that. So you get much beyond that, and it basically you send a message, and your grandkids will get the reply from that. So we're really looking for things that are very, very close to us, and fortunately, we found several thousand that are right next to us. These microlensing exoplanets, what that is basically, and this is not a technique that we will actually learn here, because you'll see that there's actually very, very few of them, just individual dots. But whenever a planet passes in front of a very distant star, it can make that star get brighter, because the light bends, gravity bends the light around, and so you get two images of it. Now, it's too far away for us to see two physical images of the star, but it makes the whole thing brighter. So we see that brightness, and we can, based on how much that brightness increases, we can tell, okay, was this a planet or was it not? This is fairly new. Most of the planets that we found have been using the techniques that we're going to teach you. Okay, so just kind of as a summary here, this is going to be just a really short lecture for you, because I want you to kind of get used to the ideas of what we're doing. Most of your lectures are going to be, the videos will be 25, 30 minutes, but then you're also, of course, going to have to pause it and then do the exercises that we have in between. So it's going to add a little bit of time to it. You figure that normally our class is an hour and 15 minutes twice a week. And so the lectures that I'm giving you here are the same lectures that I would be giving to you if we were in person. So about 2.5 hours a week for lecture you should plan, and then another 2.5 hours for lab. Labs generally from an hour to 2 hours. is what it's going to take you. It's pretty rare for anybody to finish it in less than an hour. And it's also pretty rare for somebody to take more than 2 for that, particularly if you're coming to work with me. All right. So, just in summary, then 3 areas of astrobiology: astronomy, biology, and planetary science. And then here are some of the questions that we need to answer. But there's a whole lot more than this. So, one of the things you're going to do for your homework is you're going to be exploring this right here. So, when you finish your homework, ideally print it out. I realize not all of you have access to a printer. If you don't have access to a printer, you can type it up. Well, see me in live help because we'll talk about some of the better ways to do that if you can't print it out. But if you can print it out, that's ideal. You can handwrite your answers in there, take a picture with your cell phone, upload it, and you're good to go. All right. So your next steps then, you want to download that Finding Aliens practice worksheet. Let me move my video out of the way here. Get it from Canvas. Then, like I said, either fill it out and scan it. Now, I grade these manually. I read everything that you write. So I will be using the rubric that's online, so you know exactly what I'm looking for when it's there. I will grade it in the rubric, and then you'll see your grade in Canvas. Once you see your grade in Canvas, and that'll be Monday morning is when I do all my grading. So by Monday afternoon, you generally will see it. When you get into Canvas, from Canvas you can go in there and you can look at the rubric and you can see what I've marked, and that's how you'll be able to tell what you got right, what you need a little more work on from that. All right, so it's kind of real important that you go back and you look at that. I mean, you look at your grade and you go, oh, I got 7 out of 10. I don't know why, because remember, we're building tools. We're building tools that you can use towards that final project. So it's real important that you understand each one of these tools. All right. Okay, so that's it for this one. Like I said, this is a pretty short one. They aren't normally going to be this short, but I want to try to give you time to fix some of the problems and also definitely to get started in Smart Sparrow. So what I want you to do now is log on to Smart Sparrow, make sure that you can access it, and get started on it. If you have any problems getting started in Smart Sparrow, you need to get in touch with me right away because that first assignment is going to be due on Sunday. All of the deadlines are hard deadlines. I don't accept late work. So it's not a class where, oh, I'm going to put it off and then I'll just get caught up. No, you'll just get a 0 and you probably won't pass either. So this class is absolutely doable by every single one of you. It doesn't matter what your math background is. Yep, we're going to do some math, but I can help you with that. If that makes you want to curl into a fetal ball and rock back and forth, just come see me. I can get you through it. I can help you get what you need from it. But every one of you can do it, but you will have to do the work. That's what it comes down to. Every student I've ever had who has done the work has done extremely well. People tend to get either, high B's or A's or F's from that. Because if you do the work, you understand it. And I'm not just giving you the grade, it's because you actually know what you're doing from that. But if you don't do the work, you're not going to pass. That's just the way it is. So go ahead and get started in Smart Sparrow, do the lab, make sure that you can get access and make sure that you can get everything going. All right? We'll see you next time.